In this lecture, we're going to be writing the code that moves our characters. First, let's get rid of start and update. Next, let's add a variable to hold a reference to the character controller attached to the player game object. We need to define how fast our player moves. Let's create a public variable of the type float, call it moveSpeed, and set the default value to 5f. We also set the moveSpeed variable to public, so we can change the value in the inspector in Unity anytime we want. We need a private variable to store the movement velocity of the player. Let's call it _movement velocity. Don't forget, we also need access to the player input script we just wrote. So let's declare a variable of the type player input to hold a reference to the script. Next, let's get and store references to the character controller and the player input script when the game starts. I personally prefer to get and store the references in a wake function rather than start function. A wake function is a built-in Unity function that is going to be called when an instance of this script is being loaded. It's called before the start function. The next thing to do is calculate the movement velocity for the next frame based on the player input. Let's create a function to do so and call it calculatePlayerMovement. First, we're going to set the movement velocity with the incoming player input from our player input script. We leave the value of the y-axis to 0 since we don't want to move our player upward or downward. Importantly, we need to normalize the movement velocity by calling a built-in function in vector3 called normalize. If we don't do this, the player will move faster when it's moving diagonally. We also need to rotate the movement velocity to match the camera view angle. To do this, we use quaternion.Weller to modify the rotation to align with our camera, which is 0, -45, 0. And multiply _movement velocity by this rotation. Also, don't forget to multiply _movement velocity by moveSpeed multiplied by time.delta_time to make the movement smooth across frames. Time.delta_time is the time passed since last frame, because we're going to be calculating the movement in fixed update every frame, and every frame could be slightly different in length in different hardware, sometimes even on the same hardware. So we need to multiply _movement velocity by time.delta_time to make sure the movement is constant across different frames and hardware. The next thing to do is call calculatePlayerMovement from fixed update to calculate the movement velocity and move our player every frame. After the movement velocity is calculated, we can move the player by calling the move function on the character controller and pass in _movement velocity. Please keep in mind that we should always put the code that moves objects in fixed update function. Hit Ctrl S to save our script and return to Unity. Let's click the play button at the top to test our code. Seems like it's working perfectly, but when we walk down the stairs, the player just floats in the air and doesn't drop downwards. This is because we haven't handled the vertical movement. Let's fix this in the next lecture.